Assalamualaikum warahmatullahi wabarakatuh. It is a honor to be presenter in this International Journal Seminar TICEAS 2022. My name is Rohima Uswatun Hasanah. I am the co-author of this paper. And this paper title is Increasing Corrosion Resistance and Adhesive Strength of Metal Coating on Steel Through Electrical Coating. And this is what my research have been looking at. So let's get started. The purpose of my presentation is investigate the increase the corrosion resistance and bond strength of metal coating on low carbon steel by using electrical coating. From problema about the electrical coating method, in general still has limitation. Namely, it's easy to peel off the coating due to the lack of adhesion of the metal layer to the surface of the coat material. One of the causes, among others, is the use of the amount of stress during the coating process that is not appropriate. Therefore, it is necessary to pay attention to the use of stress, so that later the bond strength of the metal layer can be maximized. Several studies with electrical coating research objects have been carried out. Darmawan 2015 researched the effect of coating temperature and surface roughness on the corrosion rate of the electroless nickel coating of ASTM A36 low carbon steel, with variation of surface roughness 0.28 meter, 0.15 meter, and 0.07 meter, and variation in coating temperature 60 Celsius, 70 Celsius, and 80 Celsius, and with the addition of 500 Celsius heat treatment for 120 minutes. The test results show that the ruggeder the surface and the higher the coating temperature, the higher the corrosion resistant value. Wijanarko et al. 2021, who examined the effect of coating time on thickness and adhesive strength of low carbon steel with the electroplating process, using a variation of 20 minutes, 25 minutes, and 13 minutes of coating time and firmly attached. From the test carried out, the result showed that the coating time was 13 minutes with an average thickness of 0.314 mm. The average adhesive strength value was 26.79 megapascal, with 25 minutes with an average thickness of 0.216 mm was 22.58 megapascal, and the coating time was 20 minutes with an average thickness of 0.114 mm, adhesive strength of 18.95 megapascal. Solution: the increasing corrosion resistance and adhesive strength of metal coating by the voltage variation used are 6, 8, 10 volt, using nickel chrome plating. Further tests were carried out, that is the corrosion test and the adhesive strength test. Methodology: 1. Tool and material preparation. 2. Nickel plating process. 3. Chrome plating process. 4. Corrosion rate test. 5. Adhesive strength test. The material is low carbon steel was cut into test specimen measuring 20 by 20 by 5 mm, carried out at the Mechanical Engineering Laboratory of Untidar. Electrical coating process. The anode is a metal oxidation reaction that dissolves in the electrolyte to form positive ions. Then it is in equilibrium with negative ions that move toward the cathode and stick to the cathode surface so that the cations are reduced and form a layer. The longer the anode will decrease along with the layer at the cathode that is formed. The electrolyte concentration remains as shown in Figure 2, Pakpahan and Malau 2018. Corrosion rate test. The testing process was carried out set on ASTM G8 with a corrosion test equipment using the potentiostat or galvastat method by connection a 3-electrode cell using a corrosive medium in the form of a salt solution as shown in Figure 3. Adhesive strength test. The specimen to be tested for adhesive strength is coated with heraldic glue. First, follow the dimension of the dolly to be used, and after that, the dolly is attached to the top of the glue as shown in Figure 4. Result and discussion. Figure 5 shows that the higher the stress on the nickel chrome plating, the lower the corrosion rate of the low carbon steel specimen. The lowest corrosion rate value of 0.00139 mpy occurs at a voltage of 10 volts. Specimen prior to nickel chrome plating, the corrosion rate that occurs is seen as high as 0.6038 mpy. After the specimen were coated with nickel chrome using various stress, the corrosion rate decreased. This happened because the higher the voltage, the faster the process of release the coating metal ion on the anode and the deposition of the coating metal ion on the cathode. This is in line with the research conducted by Pratama et al. 2018 on nickel chrome plating and corrosion rate in motorcycle exhaust. This research proved that the higher the voltage and the strong current of nickel chrome plating on the exhaust material, the corrosion rate will decrease. Figure 6 shows that the result of the highest adhesive strength value obtained in the nickel chrome plate specimen using a voltage of 10 volt of 36.050 megapascal, while the value of the lowest adhesive strength occurred in the nickel chrome plate specimen at a voltage of 6 volts, which was 12.78 megapascal. The higher the stress, the higher the bond stress of the nickel chrome layer on the specimen. This is because the higher the voltage, the faster the anode ion transfer to the cathode, so that the layer formed is also thicker and stronger. This opinion is in line with research conducted by Asroni 2020, which states that the greater the stress used, the higher the adhesive strength produced. Conclusion: that stress had an effect on the magnitude of the corrosion rate and the adhesive strength of the nickel chrome layer on low carbon steel. The lowest corrosion rate of 0.00139 mpy and the highest adhesive strength of 36.050 megapascal occur at a voltage of 10 volt. So that's all my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.